you guys doing? I'm not from San Francisco. I'm actually from Atlanta. I sound like I come from Atlanta, right? No. Yeah? Yeah, no. Obviously, I grew up a little bit, a couple hundred miles north of here. I've been migrating southward ever since. Never did actually stop in Philly. Just kind of passed through a number of times. And I'm not sure who made the joke about, kind of the sports fans being a little passionate, let's say. Yeah, totally get that. Grew up as a Giants fan. All right, Big Blue. It was not so good last night. I was actually at the game. So if I fall asleep up here, somebody just, you're volunteered. Yeah, come up and just nudge me a little bit. Good. So a little bit about me. I am a 25-year plus, and by the way, after 25 years, you stop counting. So it's a little north of that. In technology, kind of started out in research. I actually, as a mainframe programmer. Anybody remember mainframes out there? Yeah, wow, that's actually pretty good. When I talk to a number of DevOps kind of talks and crowds, they're like, what? What? So it's actually nice that some, I'll say, experienced folks are here to talk. Right, started out in mainframe, got lucky, did a little thing called local area networks. You may have remembered those. Those are like the precursor to the networks that we know today. Ended up where nobody wanted to start to figure out how network security worked. I drew the short straw, and 25 years later, I've been trying to get out of the security business. But I'm still here, and then actually got really lucky when about 8.5 years ago we partnered up with the Cloud Security Alliance and started building out some curriculum for them that got us into cloud, got us into DevOps a lot earlier than a lot of other folks out there. And by the way, that's my 25-year college reunion, which you can tell, where else are you going to wear glow sticks on your head, have Twizzlers in one hand, and double fisting in the other. So that's me. And by the way, so if anybody's looking for a party later on, it will probably be somewhere in the vicinity of me. About my companies, I actually have 2 jobs now. First, on the right-hand side is Securosis. I kind of call that my day job. That is my independent research firm. We worked with the community to build the Cloud Security Alliance latest version of their guidance. On the left-hand side is my software company called DevOps, where we're really focused on cloud management and automation. We'll talk about a lot of those things today, but enough about me. Let's talk about the environment, right? I love to start my talks with this. One, because I studied operations research and industrial engineering in college, and Deming is a hero to us, but it really kind of sets the stage for a lot of what we've seen over the past couple of years, right? It is not necessary to change. Survival is not mandatory. And we've seen that over and over again, especially any of those mainframe folks out there, right? Remember, kind of New Year's Eve, 1999, we didn't know, hey, would the power grid work? Oh shit, am I gonna have money anymore? All that, kind of stuff. Well, it turns out we did have money. Turns out the power grid still kind of worked, but I mean, God, that was only 18 years ago, right? And it's like a foreign land when you think about kind of how technology has changed, and we're just getting going. Guys, the change that we'll see out of DevOps, the change that we'll see out of cloud, it will be unrecognizable. Kind of like when you tell your kids that when you talked on the phone, you used to have to stay within a 15-foot radius of where the phone was connected to the wall. And they look at you, and then you go, oh, Dad, next you're going to tell me you didn't have music on your phone, right? Yeah, okay. So the amount of change that we're going to see moving forward is really going to be unprecedented. So what is this DevSecOps thing? The first thing you have to understand is that it's really DevOps, right? But security people, and this is a key thing you have to know about security people, we have low self-esteem. So when DevOps happened, it was like, well, where's the fucking security? Man, there's no security. We can't have that. We feel bad enough about ourselves as is. How about we do SecDevOps? And the DevOps were like, are you kidding me? Get out security first, ha ha ha. So then, we kind of figured out, hey, maybe we'll just wedge security in the middle between dev and between ops. Is that okay, guys? And they're like, no, we're going to forget about you in a couple years anyway, but we'll let you play for a little while, right? Again, all gets back to the low self-esteem. So mindset established by DevSecOps lends itself to a cooperative system whereby business operators are supplied with tools and processes that help security decision-making, along with security staff that enable use and tuning for these tools. I have no idea what the hell that means, right? No idea. Lawyers must have written that up. Any lawyers in here before I start making fun of them? No? I don't really know what that means, right? But what it does mean is that we have a lot of processes, a lot of culture that is fundamentally changing. And to me, DevSecOps is really about having all of these things work together. And we used to tell jokes about how network and security people hated each other, and the developers hated everybody, and operations hated everybody, and everybody hated everybody. And now you have DevOps, and it's kumbaya, right? Yeah, kumbaya. Let's hear it for kumbaya. That'll be kumbaya. We'll sing kumbaya at the party later on. So just find me. So when we think about where DevOps is going, where DevSecOps is going, I guess I would ask a question. In 10 years, is security even a thing, right? Because if we really kind of play this out to its logical conclusion, security becomes part of everything, right? Fundamentally part of the development process, fundamentally part of the operational process. Low self-esteem problems aside, security really shouldn't be a separate thing. But you have to understand, anybody that would identify themselves as a security person out there? A handful, couple? So for those of you that don't know and haven't worked with security people, this is pretty much what you see, right? They come in and, remember, I mean, our job is to figure out how we're going to get killed every day. So we walk around with tinfoil hats, right? Just because we're paranoid doesn't mean they're not out to get us. Right? That's kind of the whole security ethos. When you come home at night and you talk to your significant other, and they say, "Oh, hey, honey, how was your day today?" And you go, "My day was awesome." And they say, "Well, great. What happened?" And you go, "Nothing. Absolutely nothing happened today. It was the best day." Right? Because if something happens in security, it's probably not good. So you have to think about it that way. But let's talk about this quick and dirty thing, because it was a little disingenuous to kind of say, hey, I'm going to teach you guys DevSecOps in 30 minutes, right? That's kind of like saying, I'm going to teach you DevOps in 30 minutes, right? No. It's a cultural thing, it's an evolutionary thing, it's a procedural thing. So what we're going to do is kind of talk about the three aspects, and I'm going to have to go through this stuff quickly. I will apologize. You will get links to the slides. There are actually a couple of versions of the deck here. The short deck that I'm using here, a much longer deck I've done before, about 90 minutes with a lot more examples in there. There are labs that you can follow along with. We have code samples up. I'll give you, again, that link at the end of the talk, because there's just way too much to cover in 30 minutes. So what we'll do is we take a very high-level, quick tour of secure architectures, how we build security into the pipeline, right? That's where all the magic happens, and then actually operating things in a secure fashion with 3 different levels of automation. So when we say architecture, what do we mean, right? Well, first thing, and this is something that is so foreign to most security people, right? It's the idea of fitting the infrastructure to the application. Right? What does the application need? Now, anybody ever work with, kind of databases? Yes, I'm asking just to make sure you guys are still up. I know, it's been a long morning, lots of talks, not enough coffee, I totally get that, right? But, it was funny, because when you were sitting there as an architect going, hey, I'm trying to think about what database is, you talk to the people, and the people would go, yeah, you can use whatever database you want, as long as it's Oracle. Wait, what? Well, we have a site license to Oracle, so you can absolutely use whatever database you want, but it's going to be Oracle, right? So what that meant was we were retrofitting kind of the applications and the stacks that we built to the tools that we had, right? In cloud land, in DevOps land, we can actually build the stack for what the application needs. That's totally heresy in a lot of areas, right? But that's the way things work now. That means we can leverage architecture as a security control, right? We can use it. We'll talk about blast radius, we'll talk about segregation in about 10 seconds, but the point is we can use different constructs, architectural techniques to make it a lot harder to compromise your data. We've never been able to do that before. It's incredible, right? And then we can automate the deployment and management of our security with a lot of the techniques that you use in DevOps. Folks who've grown up doing DevOps are like, duh, right? Security folks, not so much. We are generally mistrustful of everything. Automation, forget it, right? Because we've lived through the environment where you kind of said, hey, maybe we'll change the network. We'll let the machine change the network. You go boom, and half your network goes down. Well, that's the last time you do that. Right? Now, with cloud and with DevOps, you don't have a choice. Automation, APIs, all of these things are fundamental aspects of our stacks. We don't have a choice. Right? So we start with architecture. A couple of things I'll mention here. One is blast radius. For an attacker, their magic approach is compromise something, anything in your environment. Once that's compromised, then I can pivot, I can move laterally, I can get to the data that I want. Because at the end of the day, most networks are just flat, right? I get into the data center, I'm in, man. I can get at everything I need to. But in cloud, you can build different virtual, in effect, networks that provide segregation. So segmentation, segregation, these things are key security constructs. Very difficult to implement in our own on-prem data center, trivial in the cloud, right? Architecture as a data security control. Right? We can cut off network attack paths. I'll show you that in a second, and then we'll talk about immutable infrastructure. Right? So here, make the cloud provider your attack surface. What I want to do, and this is maybe a little bit hard to see, but this is an analytics design pattern we worked on with a client to basically just pull data out of their corporate data center and via a whole bunch of automated functions, move it into, in this case it's Amazon, and then kind of push it back into a spun up analytics instance right here that then does its work, sends the results back to the bucket, and then it's transferred automatically to the corporate data center only when something is in these areas. There's nowhere to attack in this design pattern. These are fungible, right? The bucket isn't there for very long. It's spun up by the Lambda function and then taken away once the data is not there anymore. No place to attack. Segregation networks as a data security control. You can download the pictures. You'll be able to. So, listen, if you want to get a picture, I'm happy to smile for your picture, but you don't necessarily have to do that. Here's another design pattern, right? Web servers, processing servers, through queuing and notifications, we don't have any direct connection between the two. Okay, oh crap, my web server level got popped. Okay, what am I going to do? I can't get to the back end, right? These are architectures, these are design patterns you can't implement in your on-prem environment. And then, everybody heard of immutable infrastructure? I would think so. It's kind of an important construct to, DevOps. But, a lot of the talks I give to security folks are like, what? Right? But that's this idea that I've got everything in my environment as code, and basically I don't patch anymore. Right? Security folks loved Patch Tuesday. Why? Because the day after Patch Tuesday is Exploit Wednesday. Right? The patch appears, the attackers look at the patch and go, oh shit, I guess there's a vulnerability. I know I got 30 days before even the best operational teams are able to patch their stuff up. So I got a window of 30 days to just go run roughshod all over environments. No more of that, right? When something's vulnerable, we basically patch, we don't even patch, we build a new image and then we cycle everything through. What does that look like? No, let's go to this one, right? What does that look like, right? So we've got a whole mess of vulnerable servers in our autoscale group, right? Autoscale makes a lot of this magic happen. What we do is we start pulling some of those out that are vulnerable. We replace them with the patched version, right? That's a new recipe that we use, or whatever vernacular you want to use. And then all of a sudden, we autoscale and turn everything around, and my vulnerable servers are gone. Right, quick, magic. We have a demo that shows how we do this in about 4 minutes, right, over about 70 different services. And I remember a little exploit called Heartbleed. Yeah, that was like a fundamental problem with the internet. Amazon patched their stuff in less than 2 weeks. Hundreds of millions of servers patched, less than 2 weeks. I can tell you it would have taken a lot longer were they to walk around with their floppy disks. That's how we used to do stuff, guys. We would walk around with floppy disks and update one server at a time. That don't scale. Immutable scales incredibly, gives us capabilities we didn't know happen. So when we say secure architecture plus DevOps is cloud security or DevSecOps, this is what we mean. Security can easily embed and automate into the same tool chains that we build our development and our operational tools. One of the things I skipped over, we'll go over in a slide or two, is a pipeline, right? But it's a pipeline, actually let me just hit this real quick. It's a pipeline for security. Right? We've got our code, infrastructure as a code, our server requirements, our packers, our security requirements in there, goes as code into our repository, and then our pipeline takes it. We do tests before it ever becomes a master image. We're actually doing security testing on stuff before we deploy it. For the one security person in here, right? This is, I mean, it's crazy. We're just like, what? We're able to test stuff before it goes live? Normally, it's being beaten the shit out of by 10,000 people before they're like, oh, maybe we have a security problem. You didn't think to ask before you deployed it to a couple million people, huh? All right? I mean, you know, again, this is magical stuff for somebody that's been doing this for a long, long time. Okay, so that's architecture. Let's pivot into our actual pipeline and protecting that. So this looks, well, shockingly enough, like another pipeline. Right, but what we have here, which is in addition to what many of you may not, typically do, is security tests in our pipeline. Again, ever heard the term shift left? Shift left, right? We've been talking about building security in for at least a decade, probably more, and that's this whole concept that it's cheaper to fix things earlier in the process before you deploy it to a whole mess of servers, a whole mess of customers, so on and so forth. Same thing goes for security. We want to shift security left as early as possible into the development process. And we can do that, right, by just building things in, building security tests into our pipeline. So what does that mean? And this, I pulled some slides out of one of the labs that we do, but this image kind of looks like a pipeline, because it is. So what we've done to build this pipeline is the first thing we do is a security credential scan. Anybody know what that is? Go ahead. Yes, scanning your environment for random keys that shouldn't be there. So you don't get a call like I got about 5 years ago from my partner saying, we have a problem. Things you don't ever want to get, right? Something happened with the kids, you're bankrupt, and we have a problem with our technology stack. Okay, maybe there's a little bit of a difference of urgency there. But go with me here for a second, right? He called me and says, well, I just got this email from Amazon, and they kind of told us that I forgot to clean out the credential before I posted something to GitHub. Awesome, right? So what happened is that somebody from Eastern Europe actually found it, spun up an extra large instance in our account, and started Litecoin mining. That was great. Again, kudos to Amazon. One, they found it for us. We didn't know. Two, they didn't charge us the couple $1,000 that the Eastern Europeans actually had run up in there. Maybe it was because we write for a living and some folks actually read what we actually write, or maybe it's just out of the goodness of their heart. Anybody venture to guess why they would have refunded our money? I don't know. I'll go with the goodness of their heart for 200, Alex. So what we can do is, actually scan all of our code to make sure that we didn't make a sophomoric error like leaving our credentials in there. Then we build it. So there's that. Packer launches an instance with the provided configuration. It runs Ansible in local mode. Ansible runs its playbook and finishes the configuration. Again, all software configured. Here's actual code that you can run in order to make this happen, right? Variables we pass in, details for creating the AMI, run the shell commands to install Ansible. All of this happens via code. All of it happens automatically. All of it is triggered by your pipeline. Then we can do our dynamic application security testing. We do vulnerability assessment on the back end of all of these, again, as part of the deployment process. And if you have the juice, if one of these tests fail, you can kick the whole deploy out of the process because of a security issue. Security people with the low self-esteem have been trying to get this done for years. Wait, there's a security problem? We really shouldn't deploy that to customers. Well, the VP of engineering says, we're incented on a couple of things, and all of them are ship the fucking code. So help me understand where your security tests fit into that, right? So now, because it's all automated, we can kick it out and it becomes a defect just like everything else, because that's what it is. Shift left. Right, and we can actually automate the security testing. A couple of tools here, Mitten, Gauntlet, BDD. We'll talk here about, kind of this is an actual snippet of using Nmap to test your network as part of your stack. Remember, networks are code in this new world. Infrastructure is code. We can use Gauntlet to test to make sure that we don't have open ports in our networking stack, right? And that's what the code actually looks like. And then we deploy it. Right, so pulls the AMI from the console log, runs the rolling update script. Due to the magic of auto-scaling, we're able to continue to roll this out, and magic happens. You deploy secure environments, either as code, instances, or containers, right? We can just, it's code. We can deploy it any way we need to. So that's building code into the pipeline. How about operations, right? Talked about architecture, we talked about security into the pipeline. Now let's talk a little bit about operations. And secure operations is all about automation. And what we have are 3 different levels of automation within kind of the whole operation structure. First, we'll dig and spend a lot more time on is guardrails, right? Anybody heard of that term before? Almost nobody? Yeah, so this is the idea of, you basically going down the mountain at a high rate of speed. Anybody ever drive over the Independence Pass in Colorado? Anybody? It's beautiful. Try to do that if you ever get to. I got there inadvertently because Waze, remember these Waze? Man, you end up in some weird places with Waze. I mean, it's like starting to snow. It's October. I got a rear-wheel drive car in Denver, which sounded like a great idea. And next thing I know, I'm on the Independence Pass. It's about 32 degrees and snowing. And I'm here. That's amazing. Because I'll tell you, the Independence Pass has no guardrails. It's like a road carved into a mountain. And you drive up to it and you go, wow, that's cool. Who would be stupid enough to drive there? And 10 minutes later, you're like, oh shit, that's me. I would have felt a lot better if I had guardrails, right? Allow me to go fast, but not drive off the road. It's a very similar type of analogy with DevOps. Right? We want our developers, we want our operations people to move as quickly as they can, but we don't want them to drive off the road. We want to put guardrails around their environment. Then we want to kind of structure and build a bunch of more complicated ideas, right? Workflows that kind of work together to automate complicated functions. And then the last version is orchestrations, where we start building third-party technologies into our workflows, right? Everything is available via an API, so we can do that kind of stuff. Here are a couple of principles. One, everything is software defined. We talked about it a lot. Everything needs to be stateless. We can't guarantee that we have access and visibility into everything that's happening, every transaction that's happening. This is not a place where I can tap the network and then look at all the packets. Right? We have to work in a stateless environment. We want it to be event-driven, meaning something happens, then I take other action, and finally we have to learn. Because if we don't have continuous feedback, it doesn't work out very well. Here, we have to make sure that the cloud service provider can do things, and we also have to have things in place to make sure that we're ready for it. So what are guardrails? Right? These are these ideas I described. An environment that enforces best practices in our cloud and our DevOps type of environment. We want to be able to do different things in dev than we do in prod, right? We can open things up in dev because only the developers have access to that environment. Production, not so much. We want that thing locked down as tightly as we can, right? We want to be able to have different guardrails for different environments. Find the deviations, evaluate the issues, and then fix it automatically. That's the difference. Right? And there are vulnerability scanners. I'm sure most of you have heard of the vulnerability scanner. Right? These are wonderful tools. They run in your environment and they deliver a 200-page report of stuff you're never going to fix. They are awesome. Right? It just creates more noise. So the idea of a good guardrail is not just to tell you something is wrong, which you need from a reporting standpoint, but to actually fix it before somebody gets hurt. And then teach the folks. So here are a couple of different examples. Again, you can look at them, but some of the ones we like, right? If you find a public S3 bucket, kind of restrict it to a known IP address range. Don't take it off the network, right? But restrict it to a known IP address range. right? Require MFA for any API use, not just console use. Find instances with an IAM role that allows power user or greater access via the API. Again, these are things that should not happen. They're best practices to not have these things happen in your environment. When they do, we want to stop it because, you know what, it could be a misconfiguration or a mistake on the part of somebody in your environment, or it could be malicious activity. Either way, it doesn't matter. You want it to stop. How do we build the guardrail? Define your criteria, add your filters, set your triggers, and let's see, I forget this, right? Add actions and add targets. Right. So here's an example we'll use, right? Criterion issues. All instances with port 22, that's an open admin server. We don't want that, right? We are working in an immutable environment. Nobody should be logging into anything, so we have to be able to lock that down. Filters, triggers, and then actions, we want to lock it down to our address range. We have some code. Again, these actually the code will be in our GitHub repository, so we have the links there. And actually within the folder I'll give you at the end of the talk, the Python scripts are in there as well. We can do event-driven guardrails as well. So this is the idea that if somebody changes your security group, you want to change it back, right? Because nothing good happens when somebody opens up everything to the worldwide internet. Right? Nothing good happens there. So there's this idea of self-healing networks. This is something that security people have laughed at for decades. Right? Anyone remember a little company called Cisco? Ever heard of them? Well, they came out with this thing called the self-defending network, and anybody who knew anything about security or networks laughed. What the hell do you mean self-defending network? Well, it turns out it's actually a thing now. So with a guardrail, right, here's how that would work. A change in a security group, the event is recorded to CloudTrail, it's passed to the CloudTrail log stream, triggers a CloudWatch event, then we have a Lambda function that's built specifically to watch for that event that then changes the security group back to what your accepted security group policy is. Right? Happens automatically. So before you even know there's a problem, it's been fixed. That's a guardrail. Go down the hill fast. Don't drive off the mountain, right? Normally here, if I had more than 2 or 3 minutes left, I'd show you DevOps, because that's what we do. We implement guardrails. For workflows, again, similar type of thing. Define your steps, determine the inputs, choose how you're going to execute and modularize the code. One example that, again, I won't go through here, but you can look at it in your slides, is this idea of incident response. So in the old days, we would have to quarantine the device, do a whole bunch of forensics on it, snapshot the actual device, make sure that everything's there, do a bunch of analysis. It took, if you were really good, a couple of hours. If you were not so good, a couple of days. Here, I actually could show you, I'm not going to show you now, but we can do it in about 2 minutes. Right, which what that means, and it's less actually, which what it does is it pulls the instance in question off of your network, puts it in a group that's only accessible via security, automatically snapshots it, spins up a internet forensics jump kit, connects to that instance, does a bunch of analysis, gives you information about that before it ever shows up on a responder's desk. So they already have pretty much everything they need to get going. Saves a huge amount of time, and through the magic of auto-scaling, takes that instance offline, replaces it with something else. Your customers don't know the difference. So workflows are to speed up common manual tasks. And then again, use your pipeline. That's the thing about the workflows. Actually, that's the thing about all the automations. Use your pipeline to test it, to make sure it doesn't break stuff before you deploy it. Orchestrations, again, actually just kind of adding a third-party technology in here. The demo that we have is an open web server that is not behind a cloud WAF. So what we show here is that with, let's see, this will run in the background while I describe it. What we have is looking at your cloud environment, seeing if any of the instances have port 80 open. If it has port 80 open, it's probably a web server. If it's a web server, we check with Encapsula, which is a cloud WAF through their API, to see if the actual server is provisioned in their environment. If it's not, we change DNS to route it towards Encapsula. We provision it in Encapsula. Voila! Within about less than a minute, any open port 80 server that shows up in your environment is protected behind the WAF. Magic. The complexities that we have to worry about, obviously it's great. You can build a script to do all of these things, and we give you some technologies to do that. That's wonderful. But what happens when you have to do this across multiple accounts? Well, that means you got to actually implement the scripts in all of these different environments, right? That's a problem. Multiple providers, same thing, making this thing scale. And then this idea of circuit breakers. Anybody ever watch BattleBots? Yeah, that's fun. Come on, man. You lying to me now? This is a group of technology people. Of course you're watching BattleBots. So you get the BattleBots. Well, basically, if you have an automation or a guardrail that's put in place by the dev team, and you have a workflow that's put in place by the operations team, and they're contrary to each other, who wins? Not your CFO. Right? You're spinning stuff kind of all over the place. So we have to make sure we have circuit breakers so that if something does run out of control, we don't crater everything. So where do we start? We start with something simple. We build it in one account. We build it in a library. Remember, it's code. It can be modular. Add enterprise scaling capabilities and make sure you use your pipeline to manage all of this. So there is no quick and dirty DevSecOps. Sorry. Right? I know I promised I would teach you about quick and dirty DevSecOps. Doesn't exist, right? Cultural change, process change. We want to, again, just piggyback on a lot of the processes that you've already built for DevOps. Look to integrate the security mindset into your DevOps culture. Security is everyone's responsibility. That is a platitude, but it is actually true. And I am of the opinion that DevOps survives, Sec gets embedded within the two, and then I can go sit on a beach and drink something fruity out of a pineapple. Because that's all I want to do. I don't want to do the security thing anymore. It's hard. It's hard. I just want to drink fruity stuff out of a pineapple. There, securosis.box.com/V/Q, capital Q, capital D, capital D, capital S, capital O, quick and dirty DevSecOps. Not too smart. I needed the acronym to, kind of, so I could remember it, right? Quick and dirty DevSecOps. There you will find 2 totally bloated PDFs, one very large, which is the bigger presentation, the other not as large, still bloated because my PowerPoint people don't know how to build a goddamn template. So I turned what's a 30 megs thing into a 150 meg thing, but internet is free now, right? Bandwidth is free, so storage is free, so too bad. And we have a bonus section there on open source tools and container security. So check that stuff out. We've got code snippets. And I'd be remiss, and I would be fired by my second job, which I don't get paid for anyway, if I didn't tell you that you could follow along with DisruptOps at our mailing list. We are going to go live at the end of this month with an early access program. So again, implement guardrails in your environment. Make sure you don't drive off the mountain. And with that, did I finish on time? Close? Close. Close. Thank you, guys.